Hello there and welcome to a brand new lesson. This is Hard Beyond Numbers where we learn maths the easy way. And in this lesson, we are looking at multiplying and dividing rational functions. In our previous lesson, we looked at adding and subtraction of rational functions. And here are the answers to the trial questions I gave. I do hope you were able to get them. If not, you can quickly look at the answers and then check or let me know in the comment section what you got wrong and what you might need help with. Now, in this lesson, we are looking at what multiplying and dividing rational function. By the end of this lesson, you should be able to multiply rational expressions by multiplying the numerators and the denominators. You should also be able to use the cross cancelling to simplify before multiplying. When it comes to dividing, you should be able to use the keep, change, and then flip to what evaluate divisions. And then we should be able to factorize fully before cancelling common factors. And finally, by the end of this lesson, you should be able to state restrictions based on the original denominators. As usual, I advise you pause and quickly look at these vocabularies. We'll be using them as we proceed in the lesson, and it would pay off if you pause and quickly take a glance. So without much ado, let's quickly go into the lesson. Now, when it comes to maths, it is good you solve or learn with examples. But before we go to the examples, let me explain what we have to do. When it comes to multiplying or dividing rational functions, if you have P over Q and you are multiplying it by R over S, then all we want to do is you multiply the P by the R. That is, you multiply the numerators. So that you have what? PR all over QS. But then it is important to take note that if there's any simplification, we always want to do that. So in order to do that, you always factorize first before any operation. You see, so if you're able to factorize first, there may be common factors that will cancel out. For instance, if you are to multiply A over B times, let's say, a BD all over a CA. If you were to multiply this, then it is best you first of all do your cancellation. You see, then with that, you'll be left with just a D over C, which is very simple. You see, so whether you multiply before evaluating or evaluating before multiplying, at the end of the day, you should get the same answer. But to be on the safer side and then to avoid working with larger numbers, you should always simplify by cancellation before you multiply. Now, when it comes to the division, then we use the keep, flip, and the multiply method. So that is to say, if you have P over Q, you are dividing it by what? R over S. You keep the first term, which is what? P over Q. Then you change this we have here, the sign, to multiplication, and then you flip this second one so that it becomes S over R. If you are able to do this, you have changed your question from a division perspective to multiplication. Then you use the same steps we needed for multiplication. Now let's quickly solve some examples so that at least you'd get to understand what we are talking about over here. Now with our first question here, we want to try something on the simplification even before we go to the multiplication. So if you have this as the first fraction and you're using it to multiply the other, and you want to simplify this first, how do you go about it? So we have x squared plus 5x and then plus 6 all over x squared minus 4. Now working on the numerator, which is x squared plus 5x and then plus 6. When it comes to quadratic factorization, if a is 1, then all we need to do is to take our 6. Then we look for the factor pairs of 6. That when we multiply, we'll get 5. When we multiply, we'll get 6. But then when we add, we should get what? 5. These factors are 3 and then 2. If you multiply 3 by 2, we'll get 6. And if we are to add 3 to 2, we are going to get a 5. Hence, when we want to factorize this, that is simply going to be x, then plus 3, and then x plus 2. As simple as that. Now, with this that we have factorized, take note, the denominator is also going to need factorization because there is x squared minus 4. And x squared minus 4 is simply difference of two squares. That is x squared minus 2 squared. X squared minus 2 squared gives us an x minus 2 and then an x plus 2. So with this, if you want to substitute into what we have over here, then we are going to say the numerator is going to be what? X plus 3 times x plus 2 all over x minus 2 times x plus 2. And with that, when we say we want to cancel out, then all you are doing is to take note of the common factors, that is of both the numerator and then the denominator. So you can see that we have x plus 2 on both. So they cancel out, and then we'll be left with what? X plus 3 over x minus 2. So we have x plus 3 over x minus 2 as our final answer for this simplification. So take note of this, as it would help us to simplify when multiplying and dividing. Now, it is important that anytime you finish your evaluation, you'd always state your largest possible domain. That is to say, if you have x plus 3 over x minus 2, which values of x shouldn't we put inside? Shouldn't we substitute as the values of x? So what you do is you evaluate or you equate your denominator to 0. Equating our denominator to 0, you know our denominator is simply x minus 2 and then x plus 2. If you are equating this to 0 and then solving for x, we are going to get x equals 2 and then x equals minus 2. You see? So we know when it comes to rational functions, if the denominator gives us 0, then you are going to get an undefined expression. So we need to state here that we should put all values of x, but then the x should not be equal to a plus or minus 2. This would be our restriction for this function we have here. With that said, let's now see how we can apply all this in multiplication and division. With our first question we have, it says we have to multiply x plus 3 over x minus 1 by x squared minus 1 all over x squared minus 9. Now, as I said, you can quickly go your way and multiply numerator by numerator and denominator by denominator. But that is not always the best thing to do. Let's see whether or not we can do some simplification. Realize that this here is a difference of 2 squared, and this is also a difference of 2 squared. And that is to say, x squared minus 1 gives us an x minus 1 and then x plus 1. And then on the other hand, we have x squared minus 9, which is also a difference of 2 squared. That is x squared minus 3 squared. And that gives us, so for x squared minus 9 squared, we have x squared, x minus 3, and then an x plus 3. So we are going to do the necessary substitution so that we determine whether or not there are some cancellations we can make. So we have x plus 3 all over x minus 1. And that multiplies, instead of x squared minus 1, we are going to rewrite it as x minus 1 and then x plus 1 all over x minus 3 and then x plus 3. So with this, we have we can now see if we can cancel or not. Now, talking of cancellation, the x plus 1 we have here is the same as what we have over here. This x plus 1, so they can cancel out. And the same way, this x plus 3 we have here can also cancel out this x plus 3. If you do all these necessary cancellations, that is, if this cancels out this and this cancels out this, then for this particular fraction, we are going to be left with just a 1 over 1. Multiplying, if this goes off, we have x plus 1 over what? X minus 3. So with that, we are going to get an x plus 1 over x minus 3 as our final answer. But as I've always said, state your restrictions. And your restrictions are going to be obtained from the original fractions denominators. You see? So with that, if x minus 1 is equal to 0, then x becomes what? 1. So we are going to say x should not be 1. And for this as well, if you have x squared minus 9, which is x minus 3, x plus 3, being equal to 0, then x would either be 3 or minus 3. So you're also going to say x should not be equal to either a plus or minus 3. So this becomes our answer with its restrictions stated clearly over here. So this is basically how we do our multiplication. Very simple. Choose to factorize first if it is possible, and then do your simplification. You get your answer and state your restrictions. Now let's look at how we can apply this as well in division. So what we have here with regards to division, it says x squared minus 4 over x plus 3 divided by x minus 2 over x plus 3. How do we work with that? So we have x squared minus 4 all over x plus 3, and we are dividing it by x minus 2 over x plus 3. So the first thing we need to do is to what? Keep the first one, change the division sign to multiplication, and then flip the second one. So that is x squared minus 4 all over x plus 3. Then for the division, we say what? Times. Then we now flip the second one. So the numerator goes to the denominator goes to the numerator, and then the numerator comes to the denominator. So that we have x plus 3 over x minus 2. So this has now become a multiplication problem. You see, so if it is a multiplication problem, then what do? This here can be factorized. Factorizing that gives us an x plus 2. That is a difference of 2 squares. So x plus 2, then x minus 2 all over x plus 3 times x plus 3 over x minus 2. So with what we have here, if we want to cancel out, then this x minus 2 takes out the x minus 2. So that after the cancellation, we are going to get an x plus 2 over, well, the x plus 3 over here as well is also going to cancel out this, you see. So after that cancellation, we are going to get just an x plus 2 over 1, then times this has also been cancelled, so 1 over, and this has also been cancelled, over 1, which then gives us an x plus 2 as our final answer. So yes, this is our final answer, but we need to state the restrictions. To state the restrictions, we come to our original question. That is where we started everything. And you realize that for this, if the denominator is 0, it is not going to work. And the denominator is 0 when x is negative 3. So we say x should not be equal to -3. And same applies here. The denominator is 0 if x is equal to what? 2. So x should not be equal to 2 as well. So this is our function. That is our final answer. And these are its restrictions. Now, to get more into details of why these should not be in our domain, then you can look at our lesson on the wholes and then the asymptotes so that you get to understand this. So this is it on division. Let's then look at more challenging questions just to enhance our understanding. So this is question number 4. And question number 4 says we are to multiply with factoring. That is, simplify 2x squared minus 8 all over x squared plus 4x plus 4. Then times x plus 2 all over x minus 2. So what do we have here? 2x squared minus 8 all over the x squared plus 4x plus 4, then times an x plus 2 over x minus 2. So we can work on this first of all by factorizing. Now take note, we have 2x squared minus 8. You should always be observant to be able to tell whether or not we can factorize or not. If you realize there's any possible factorization, just work it out because it would help you in your cancellation. For the numbers, there is 2 and then there is what we have here as 8. So we can factorize the 2 out so that we have a 2 into bracket and x squared minus 4. Now this x squared minus 4 itself is a difference of 2 squares. So that extends to give us, first of all, we have our 2. So 2, then into bracket, the difference of 2 squares, which gives us x minus 2 and then x plus 2. So that means this we have over here becomes what we have here. So for that particular numerator, we are going to rewrite it as 2 into bracket x minus 2 and then x plus 2. Then we come to this second one we have here, which is x squared plus 4x plus 4. Luckily, our coefficient is what? 1. Hence, the factors of 4, that when we multiply, we'll get 4, all right, but then if we add, we'll get 2. That is 2 and 2. So this is then factorized at x minus x plus 2, then x plus 2. So we have over x plus 2, x plus 2. Then we have times this one, they are already in their linear state. There's nothing else to factorize. So we have x plus 2 over x minus 2. So with this, let me just clean out what we have here and this as well. Now we want to simplify further. So looking at it carefully, we have x plus 2 here, which can take out this x plus 2. And since they are multiplying, we can also cross cancel. So that this x plus 2 takes out the x plus 2. And also, this x minus 2 takes out this x minus 2. So looking at it carefully, what has happened? We are just left with 2. See? So we are left with 2. Literally, we are left with 2. Now, that is to say we have 2 over 1 after our cancellation, then 1 over 1, which then gives us a 2. As simple as that. Now, if you are to draw this on a graph, you are going to get a constant function. But this constant function is discontinuous. You see, it is discontinuous at x equals, so that is x should not be equal to, first of all, it shouldn't be equal to what? 2. Because making it to make this 0. So it shouldn't be equal to 2 and it shouldn't be equal to -2 as well. So it shouldn't be equal to 2 here and then it shouldn't be equal to -2 here. So x should not be equal to plus or minus 2. Now, to give you a clue as to what is happening here, that you have to tell, or you have to indicate that it is a whole, let's plot this graph. So for this particular graph, that is 2x squared minus 8 all over x squared plus 4x plus 4. This is its representation on my graph sheet over here. Now you realize that if I'm to zoom in, you see the line tries to get to -2, but then it never touches it, both the one that goes upwards and then the one that comes downwards. It tries as much as possible, even as it approaches infinity. You see, it keeps going, but it never touches the line x equals -2. With that, if we are to put the function 2, which is the final answer we had, so that is it over here, this straight line. This is the 2, is a constant, y equals 2, as you have seen me do right here. If I'm to put it here, then that is to tell you that if this is going to depend on this and this function, then as these functions are not approaching, are not being evaluated at 2, there's supposed to be a whole right here. So that is it for this. That is why the -2 will become a whole. But then for the next function, which was x plus 2 all over x minus 2, this is how that function looks like. So this is it over here. You see, so for that function as well, if you look at where the 2 is, it does not touch. The 2 part of the function does not touch where we have the 2. Hence, if this is your resultant function, that is for multiplying the first and then the second one, then it should tell you that at x equals 2, you are not going to get a result, since it is what? Since there is actually an asymptote over there. You get it? That is why it is important you state your restrictions. Now, that aside, let's solve 2 more questions that is going to be a little more challenging to test and enhance our understanding. So this is a very nice one. For the numerator, we have addition. For the denominator, we have subtraction, and we are to evaluate them both and then divide. We say simplify the compound fraction 1 over x plus 1 over y all over 1 over x minus 1 over y. So let's write it down. So how do we evaluate this? We would work that of the numerator and then divide it by the resultant of the denominator. So for the numerator, we have 1 over x plus 1 over y. The LCM, the LCD is xy. So we have our x, y, and then x divides xy, y. Then the y multiplies the 1 to give us what? A y. The same way, y divides xy, x. Then the x multiplies the 1 to give us what? Plus x. So that will be it for the numerator. Then for the denominator, what do we have? We have the same procedure, x, y. So that will be LCD. Then x into xy, y times 1 gives us what? A y. Then minus the same way we have our x. So with this that we have, let's try and then rewrite it so that we can solve. For the first one we have here, it is y plus x over xy. Then this long symbol here would be our division sign. So divided by y minus x all over xy. You see, so with this, we now go to our KCF rule. Let's keep this we have over here so that it becomes y plus x all over xy. Then the division sign becomes multiplication, so times. And then we flip this around so that we have x, y all over what? Y minus x. With this, we are going to have our xy cancelling out the xy. You see, so we have y plus x all over 1, that is after the cancellation, then times 1 over y minus x. So with that, you are going to get a y plus x over x over y minus x. You see, so initially you will think it is very challenging, but if you take your time and then you just follow the procedure, you realize that it is very, very simple. Now with this, if we want to write out our restrictions, then we come all the way here. This is where we started everything, you see. So we know that if x is equal to 0, we are going to get undefined. So we say x should not be equal to 0. The same way, if y is equal to 0, we are also going to get undefined. So y should also not be equal to 0. And then for this, if our x is equal to our y, then we are going to get y minus y or x minus x, which gives us 0 over here. So our x should also not be equal to y. As simple as that. So this is our final answer, and these are the restrictions that come with it. Let's now look at our last question to crown it all up. So this is what we have here as our final question. It says x squared minus 25 all over x plus 2 divided by x minus 5 all over x squared plus 5x plus 6. So we have x squared minus 25 all over x plus 2, then divided by x minus 5 over x squared plus 5x plus 6. How do we do this? This we have here, that is x squared minus 25, is simply a difference of two squares. Specifically, x squared minus 5 squared. So with that, we have x minus 5 and then an x plus 5 all over x plus 2. Then we have divided by, this side gives us an x minus 5 all over, since our coefficient here is 1, then we look for the factors of 6. That when we add, we are going to get a 5, and that is a 3 and a 2. So factorizing, we have x plus 3 and then x plus 2. So with that, we keep the first fraction, that is x minus 5, then into bracket x plus 5 all over x plus 2. We change our division to multiplication. So we have times, then we flip this second fraction. So that I have x plus 3, x plus 2 all over x minus 5. We can now proceed with our cancellation. So this cancels out this x minus 5. So we have x minus 5 also taking out the x minus 5. So specifically with this fraction, we have x plus 1, x plus 5 all over 1, then times, what do we have left here? X plus 3, that is also over 1. We can just ignore the over 1. So that this becomes our final answer. That is x plus 5 and then x plus 3. Now we come all the way to this side to give our restrictions. So we say x should not be equal to negative 2. That is from this particular side. And then the x should also not be equal to what? 5. Because if they are equal to 5 and then negative 2, we are going to get what? An undefined term. So this is our last question, and we would end it over here. As usual, I'll leave it some questions so you try on your own just to test your understanding. So these are 5 questions you can try on your own just to test your understanding. In our next lesson, which is on partial fractions, I'll display the answers to this question so that you can evaluate and then mark yourself. Let's have beyond numbers where we learn maths the easy way. If there's any issue of concern, you can always let me know at the comment section. If this is your first time on this channel, I think it will be of help to you. You can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson. Bye for now. Do stay safe.